Okay, guys, let's start the uh, session now. So I hope I am my screen is also my audio is also okay, and my screen is also visible. So can everyone see my screen? Can anyone please confirm that they can see my screen?
Yes, sir.
Okay, thanks a lot. So, welcome to Analog Circuits course, and congratulate every one of you to start learning from NPTEL and hone your skills. So, welcome to this Analog Circuits course, and these tutorial sessions will be kind of supplementary to whatever you learn in the course itself. So in these tutorials, the main purpose of this tutorial is that you guys can, so first of all, go work out the things that work out the assignments or maybe the concepts that are taught and have some, let's say you have some doubts in it or you want to see how the solutions of the problems happen. So you can come in these tutorials. So these tutorials we will try to keep as interactive as possible, so that you guys can always unmute yourself and ask doubts. And maybe whatever I'm not covering in the tutorial, at the end I will give time for you if you want to discuss some particular topic out of your own interest, that also we can have over here. The so what we will do initially is that we will try to solve a set of questions, and with each question I will give you some time. You guys can put your answers either in the chat window or by unmuting yourself also. And then we will see how those problems are solved, and if there are some other concepts involving those solutions are there, that also we will try to address. As far as my introduction is concerned, myself Chaitanya Kumar, I am doing my PhD at Indian Institute of Technology Madras in electrical engineering. My area of research is high speed analog to digital converters, and currently I'm in final year of my PhD, and I will be taking your analog circuits tube for next 8 weeks. So, having said our introduction, let's start with the problems for first week. So, before I start, I hope every one of you have gone through first week lectures. Am I correct? I hope every one of you have gone through first week lectures. So, assuming that, let's start with the first question. So, let's start with a simple question initially. So, the question says that question asks, what is the ideal characteristics of op amp? So, everyone knows about operational amplifier. That is basically the course is about. So, given an three-terminal op amp with two terminals being the input and one terminal being an output. So, what are the ideal characteristics of the op amp? Can you guys help me with the answer? What should be the input resistance of the op amp?
Sir, infinity, sir.
Okay, the input resistance should be infinity. What should be your output resistance? The output resistance?
Should be zero.
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 And what about the gain?
Should
Again,
be
sir, infinity.
Infinity.
Again, infinity. Okay. So output resistance infinity, gain should be sorry, output resistance zero, gain should be infinity, and input resistance should also be zero. So option one is the correct way. Now, can you guys help me understand why you need these characteristics? So let's try to see. What is the most common application of an ideal op amp? It's used to make circuits in negative feedback. Are you guys familiar with the concept of negative feedback? Okay, so let's start with where the application of such a high gain, high input resistance, and low output impedance happens. So first of all, we will try to understand what a negative feedback is. So let's say we have two terminals. So this is, let's say, V plus, and this is V minus. And our job is to compare the two terminal and make sure that the difference between the two, that is V plus minus of V minus, should be equal to 0. So this is what the op amp, high gain op amp, is used for. So let's say we have two terminals like this of the op amp, and this is basically connected like this. So we have plus terminal over here and minus terminal over here. Now, if the gain of this op amp is infinity, and this is used in open loop configuration, as in just like we give the input as V plus and V minus and take the output as V out is equal to A times V plus minus V minus. In this case, if there is even slight difference between V plus and V minus, what will happen to the output voltage of the op amp? Can anyone tell me what will be my output voltage? It will go to, so let's say V plus minus V minus is equal to some delta V. So output voltage will become A times delta V, correct? Now, if the A is very high, almost infinity, the output voltage will blow up. It will become almost infinity, assuming that this op amp is ideal and can give any output voltage, whatever it requires, and there is no power supply limit to this op amp. So that will happen. Now, let's say I connect it like this. Okay. Now, what will happen? So, in this case, what will happen is that if let's say this V plus wants to go, V plus increases to some delta V. Okay. So initially, what will happen that let's say, and V minus is at initially the same voltage as it was earlier, and V plus tried to go to a voltage, whatever it was, it wants to go to an incremental voltage of delta V. What will happen is that the output of the op amp will suddenly increase, and the output of the op amp will suddenly increase, correct? So, and since the output of the op amp is connected to the negative feedback, the input of the op amp will also try to increase. Now, what will happen is that wherever this particular voltage is going, so let's say this goes by plus delta V, this will also increase by a certain amount, and it will try to track whatever is happening at the plus terminal of the op amp. Now, this is called the concept of negative feedback. So, what happens is, however this voltage goes, the positive terminal of the positive terminal of the op amp goes, the same way the negative terminal of the op amp will track it. And what is this concept called? So, when the op amp is in negative feedback configuration, the positive and negative terminal of the op amp track each other. What is this concept called?
Buffers.
Uh, no, no. Okay, the buffer is
Voltage
the
control
application.
voltage source.
Okay,
Virtual ground.
correct. Virtual ground. So what happens is there. So whenever the op amp is in negative feedback, and negative feedback systems are always stable. So for a bounded input, there will always be an bounded output. Generally, the some systems in negative feedback are bounded input, bounded output stable. So what will happen is, since the gain of the op amp is infinity, and the slightest difference between V plus and V minus will result in blowing up of the output. Now, since the system is stable, so for a bounded input, it can't give you unbounded output. So, this negative feedback will make sure that there is no error between V plus and V minus. And this concept of tracking of positive and negative terminals of the op amp is called virtual ground or virtual short. So, there is a virtual short between V plus and V minus. Using this concept, we build several circuits like inverting amplifier, non-inverting amplifier, summer, averager, and whatnot. So all the op amp circuits that we see work on this basic principle that a high gain op amp is connected in negative feedback and gives you virtual short. Now, why do we need infinite input resistance? Can anyone tell?
Because the current to the op amp is zero. Input current to the op amp is always zero.
Correct.
Or
Input.
uh,
Yeah, yeah.
we can't, for cascading and all, we should eliminate that.
Yeah. What Vinod is trying to say is now let's say this is my op amp. Okay. So what will happen is, this positive terminal, I am driving with a voltage source. Okay. Let's say this is called Vn. So what will be my output voltage?
We
Vn only, right? So I am basically driving my input with an ideal voltage source. In this case, whatever Vin comes will come at the output as Vin. Now, let's say my positive terminal had an input impedance of Rin. Okay. So in this case also, as long as my driving voltage source has zero output impedance, my output voltage will still remain Vn. But the moment I have some source resistance over here, Rs, so I have Vin over here, I have Rin over here. In this case, what will be my output now? So what will be this voltage?
V into Rin divided by Rin plus Rs.
Vin into Rin divided by Rin plus Rs. Correct? And the same voltage will come at this node. So V out now will be Rin by Rin plus Rs times Vn. Now, in order to, so basically, whatever input voltage I gave, there was a voltage drop from input to the output because of non-infinite input impedance. So, if this Rin goes to zero, in that case, Rin goes to infinity. In that case, what will happen? The limit will be that infinity by infinity, you will get the value as 1. So, your V out will be equal to V in. So this is why your input impedance should be infinite. Now, let's say I had a finite output impedance. In that case, what will happen? The same thing. Let's say looking in impedance of op amp, Z out is equal to some R out. Okay, so how can the Thevenin equivalent? So you guys are familiar with Thevenin equivalent, right?
Yes, sir.
Okay, so how will the Thevenin equivalent look like? So so open circuit
Voltage source and
voltage source in series with
series with
output resistance.
RS.
So you have R out over here, and what open circuit voltage this gives? It gives V in, correct? So this will be V in. Now, if let's say this op amp is driving a load of value RL, so again there will be voltage division between R out and RL, and your output voltage will be V out will be RL divided by R out plus RL times V in. So again, what will happen is if my R out is not equal to zero, my V out will be less than V in. If R out is equal to zero, in that case, RL will cancel and V out will be equal to V in. So like a non-ideal model where you have some finite output impedance, some finite input impedance, and a non-finite gain, a non-infinite gain. So how will that look like for an op amp? So we will have this over here. I will have some Rin. Let's say this is plus terminal, this is minus terminal. A times, so this is Vp, this is Vm. A times Vp minus Vm, and this will be some R out. So this will be a non-ideal model for an op amp. Any doubt in this?
Oh, sir.
Okay, so now in non-ideal op amp, let's try to figure out what will be our. So let's try to figure out what will be our gain if we are in unity feedback configuration. So let's say there is some V in over here. We have some Rn over here. We have some V in over here, and this is driving an output resistance of RL. So please guys help me to write the input to output equation. So how we will start? Our Vn, Vn is equal to V out So what will be what let's call this RS. So what we will have, this will be equal to V out. So now what will be this voltage over here?
V in uh, R in divided by R in plus RS.
V in R in
R in divided by R in plus RS.
R in plus RS, and there will be one more term over here, plus V out RS by Rn plus Rs. Can you guys see this? Is this clear?
Sir, can you repeat one more time?
So, what will happen is we will just try to focus on this particular network. Okay, this particular network we'll try to focus on. So, what we have over here, we have Rs over here, we have Rin over here. This is our Vin, and this is our V out. Okay, and we want to find out this particular voltage. Okay, now what will happen is if this is given as V out, so in this case, what will happen? This the voltage at this net can be considered as a superposition between uh, V out and the voltage due to V out and voltage due to V in. Okay, so at this node, what we will have is so only due to V in, what we will have over here, Rn divided by Rn plus Rs, and only due to V out, we will have Rs divided by Rs plus Rn. So overall voltage at this node will be as follows. Is this
Okay,
clear?
sir.
Yeah.
Yes, sir.
So, okay. Now, let's try to find out what is now we are given our gain. So this voltage will be A times Vp minus Vn. So that will be, so A times Vp minus Vm can be written as A times Vn times Rn upon Rn plus Rs plus V out times Rs upon Rn plus Rs minus V out. Okay. Now this is equal to this voltage over here. So, okay, actually, there was a problem over here. The voltage due to voltage at Vp due to Vin won't be only Rin divided by Rin plus Rs. That would have been the case if R out would have been zero. But R out in our case is not zero. So the along with Rn, this R out and RL also will come in parallel to Vin. So we can't directly write Vin times Rin upon Rin plus Rs. Let's try to correct this mistake. Okay, so what we will have over here, let's still call this voltage as Vp, and this voltage is V out. So voltage at this node will simply be Vp minus V out. Okay, times A. Okay. Now, if this voltage is Vp minus V out times A, so the current that will be flowing out of the op amp will be A times Vp minus V out minus V out by R out. And what will be the current that will be flowing in this direction? This will be V out by RL. Okay. And what will be the current that will be flowing in this direction? That will be equal to Vp minus, sorry, V out minus Vp by Rn. Okay. So we can apply KCL at this output node, right? So overall the current flowing in will be equal to the current flowing out of this node. So we will have A times Vp minus V out minus V out by R out is equal to V out by RL plus V out minus Vp by Rn. So using this equation, we can find out relation between Vp and V out, right? So what will be the relation that we will get for between Vp and V out? We will separate all the terms of all the terms with Vp on one side. So we will get Vp A by R out plus 1 by Rn is equal to V out A by R out plus 1 by R out plus 1 by RL plus 1 by Rn. Okay. Is this equation, does this equation make sense to all of you? Any doubt till this point?
No, sir.
Okay. We have a relation between Vp and V out. Now, what is this current that we found out? This can also be written as, this current over here can also be written as Vp minus Vin by Rn. Correct? So what we have now is Vp minus Vin by Rn is equal to this current, right? So this is the current that flows all the way to the input. So if we apply KCL at this particular node, this current flows out, this current flows in. So both of them can be equated. So Vp minus Vin by Rn will be equal to,
So Vp minus V divided by Rs only it will come. So how
sorry,
can
Rs,
it will
Rs.
be?
It will be Rs. Correct. V out minus Vp by Rn. Okay. So again, we can put all the VP terms on one side. So we will have 1 by RS plus 1 by Rn is equal to V in by RS plus V out by Rn. Is this correct? Is this clear? So VP over here we can substitute. So we can substitute VP in this equation and VP in this equation from VP over that equation, and what we will get is V in by RS plus V out by Rn times A by R out plus 1 by Rn is equal to this over here. Now we shall try to apply the limits on this equation. So A tends to infinity, correct? If A tends to infinity, which of these two terms will dominate? So if A tends to infinity, 1 upon Rn in addition with A by R out can be ignored. Okay. So this can be written as V in by Rs plus V out by Rn A times A by R out is equal to V out times, again in this part of equation as well. What we will have is this term will be much larger than rest of the terms, because A plus 1 will be much higher than 1 by RL and 1 by Rn. So we will have over here A plus 1 by R out. Okay. Is this clear? So what we will have over here is R out can be cancelled. Just a minute. We will have one more term over here with this thing 1 by Rs plus 1 by Rn. So what we will have is V in by Rs plus V out by Rn times A is equal to V out times A plus 1 divided by 1 by Rs plus 1 by Rn. Okay. So now what we have is other so Rs cannot be so Rs can be anything, right? What should Rn be? Rn we saw that should go to infinity, correct? So if Rn goes to infinity, 1 by Rn will will tend to 0. Correct? So both these terms can be ignored. So what we have at the end is V in is equal to V out A plus 1 by A, or V out by V in is equal to upon A plus 1. Now, as the value of A keeps on going higher and higher, A upon A plus 1 can almost be approximated as 1. So, if Rn was tending to infinity, A was tending to infinity, and R out was tending to 0, V out by V in this particular circuit will be equal to 1. Is this clear?
Okay.
Okay, so let's move on to other question. So now we have an op amp in a negative feedback configuration, and we are to find out what will be our output voltage. Okay, so how we will go about solving this? Now this op amp can be so op amp in the figure is ideal. Now if the op amp in the figure is ideal, A tends to infinity. In that case, what will happen? Our we will have virtual short between plus and minus. So if this voltage is equal to 0, this voltage will also be equal to 0. In that case, what will be our output voltage? What will be the current that will be flowing from? So let's call this branch 1. This let's call as branch 2. What will be our current flowing from flowing in branch 1? Okay, what is the impedance of a capacitance?
1 by SC.
1 by SC. So, what will be I1, the current flowing in branch 1?
V1 sin omega t divided by 1 by SC.
V1 sine
Sin
omega t
omega t divided
divided
by
by 1
1 by
by,
SC.
and what is
SC
S?
J omega.
J omega, correct? Divided by J omega. So, this is equal to J omega V1 times
Sin omega.
sine omega t. What is I2?
J omega V2 sin omega.
J omega V2
Sin omega.
sine omega t, correct? So now can any current flow in this direction?
No.
No, right? So where will I1 and I2 flow?
The capacitor that is negative feedback.
This capacitor I1 and I2 will flow through, right? So what we will have
Addition of
is, so overall current will be current that will be flowing from branch 3 will be I1 plus I2, and that will be equal to j omega times
V1
V1
plus V2. V1 plus V2
V1
sin
plus V2
sin
sine omega t. Now this voltage was 0, right?
yes.
This voltage was 0, and there is some current, this I1 plus I2 flowing through I1 plus I2 flowing through this capacitor. So what will be the voltage drop that will occur across this capacitor?
V1 plus V2 sin omega.
So it will be this current times the impedance, right? So this current I1 plus I2 times the impedance. Impedance is 1 by j omega. Okay. So so final voltage drop, voltage across the capacitor will be V1 plus V2 sine omega t. Now, so what will be the output voltage?
Minus of the values.
Minus of the value, because the voltage drop occurs from the left plate to the right plate, and since the virtual ground voltage over here is zero, so output will be zero minus the voltage drop. So we will have minus V1 plus V2 sine omega t as our output voltage. Is this question clear? So we will have this capacitance over here everywhere. So now let's say I had so in the same question, let's say I had C1, C2, C3. In that case, what will happen? Can you guys quickly tell me what will be the output voltage? So now what will our currents be? Our currents will be, we will have C1 over here, we will have C2 over here. So our final I1 plus I2 will be C1 V1 plus C2 V2 times j omega sine omega t, and our voltage across the capacitor will be 1 by C3 times C1 V1 plus C2 V2 sine omega t. So our output voltage will be minus of this. So what we achieved with this is, by changing the value of capacitances, we were able to achieve. So this was a summing amplifier, and by changing the value of the capacitances of C to C1 and both the capacitances to C1 and C2, we were able to do weighted summing. Okay, is this clear? Vinod, if possible, can you move to a little quieter place? There is a lot of background noise coming along. So, if we simply change the values of the capacitors, we can have weighted summing instead of a regular summing amplifier. Is this clear? So, guys, one feedback I want from your side is the level of the questions okay, or I shall increase the level of the questions? All these concepts are understandable to you. Shall I increase the complexity of the questions or reduce it, or is this okay? Can anyone please comment on this? So guys, my question is that we have had two questions till now, right? Do you think that these questions are too easy, or so I shall increase the complexity of the questions, or the questions that we are doing are of acceptable level?
So
Okay, we
these
will.
questions are fine.
Okay, we are seeing most of them as acceptable level. So we will try to gradually increase the complexity. So, one quick demographic, can you guys help me with? Most of you are in which year of your bachelor's? So, I hope everyone is BTech, right? So, most of you are in which year of your BTech? Can you guys quickly paste in the chat window? Second year. Okay. What about third year, second year, first year? So, mostly I think are either second or first year. Am I correct? Okay, so mostly our second and first year. So I think concept of virtual ground and all those things are you might have recently studied. So we can have more questions like this. Are you guys familiar with transistors till now? So transistor, small signal model, and all those things. Small signal incremental analysis. Is incremental analysis familiar to you guys? Small signal model of transistor. Okay, so incremental analysis is not has not been taught yet. Okay, so we will try to keep it. Okay, thanks a lot, guys. With this input, we can proceed further. So now this next question might be a little alien to some of you. So it's asked that if the differential voltage gain and common mode voltage gain of a differential amplifier are 48 dB and 2 dB respectively, then what is the common mode rejection ratio? Now, are you guys familiar with differential gain and common mode gain? Little, no, sir. Okay, so we will just quickly talk about what is a differential circuit and what is a single-ended circuit, and then we will see what is differential gain and what is common mode gain. Now, what is a single-ended circuit? So let's say it has a single input. There is some gain between that, and we have some output over here. So V out is equal to A times V in. Now this is a single-ended circuit. So we have a single-ended single input, and we have a, single-ended output. This is a single-ended circuit. Now, what is differential circuit? So a simple differential circuit is our op amp. So we have two inputs. Let's call this VP. Let's call this VM. Our gain is, output is A times VP minus VM. Okay. This is a differential circuit. Now, where is this differential circuit used? So how it can be used is now what happens in the single-ended circuit? What is the problem or the issue with the single-ended circuit? Any voltage that is applied to the input is so absolute voltage doesn't make sense. Okay. Voltage is always considered as with respect to some ground. Okay. So this V in that we are saying that this particular node is of voltage V in will be with respect to some ground. Okay, you will have some input voltage at this node that will be on ground on one side. So you will say that this so node 1 is at a voltage V in with respect to this ground. Now, this ground in practice can have some noise. So, this ground can jump like this. Okay. So, instead of actual 0, it can be, let's say, 0.1 or maybe minus 0.1, and its value can keep on changing. So, this can happen is so let's say there is a huge chip that is there with you, and it has got a single ground. Now, what can happen is so there can be some resistance, some series resistance, some wire resistance of the ground. Now, if the current flows inside this, some non-zero current flows inside this ground due to some resistance that this ground has, this voltage will not be equal to zero. It will have some noise in it. Now, what will happen is if there is some noise in your ground, your input voltage will also have that noise, correct? So that same noise will come at your input voltage also. And if this noise is there, that will get amplified with your A times the input. So this way, the noise of the ground can also come up at your output voltage, and this is not a good thing. Now, in differential circuit, what happens is ideally what should happen. So Vp will be defined with respect to a ground. Vm will be defined with respect to the ground. Both these grounds will be the universal ground of the chip. And if there is some noise on both of them, so both of them will cancel each other. And at the output, you will get a noiseless signal. Is this correct? Is this clear to you guys? Okay. So, differential circuit basically eliminates supply noise, ground noise, and give you a clean output signal. So, ideally, what should happen is, so let's say my VP is uh, some x plus a sine omega t, and my VM is some b plus x plus b sine omega t. Okay. So a differential signal that we will have is Vp minus Vm, or let's write it like this: x plus a sine omega t. This is x minus a sine omega t. Okay, so differential signal, what we will have? We will have it as 2a sine omega t. So output in this case will be, uh, let's not confuse ourselves. So let's call this V, V, and this one is V. So output will be 2a times V times sine omega t. The difference between Vp and Vm gained up by the gain of this amplifier A. Okay. Now the so this is the differential signal. So common mode signal will be the average of the two, Vp plus Vm by 2. What does common mode means is that what is the signal in both of them that is common to each other. Okay. So their average will be called as common mode signal. So that will be equal to X. Okay. Now, ideally, if this differential amplifier was ideal, in that case, the will output voltage have any component of X? So, should this differential amplifier's output voltage have any component of X? So you can see, right? So output voltage ideally is A times the difference between the two signal. So whatever this X is, it shouldn't affect your output. Okay. This is there in ideal case. So what is the gain? This final output voltage can be written as 2 times A V sine omega t plus 0x. Correct? So what we have is the gain of the common mode. The common mode of the input is X. The gain of the common mode is 0. The gain of the differential mode is A. Okay. So common mode rejection ratio is basically A differential divided by A common mode, which in ideal case would be A by 0, that is equal to infinite. This means that an ideal differential amplifier should reject any common mode signal that is coming in at the input. But what happens due to several non-idealities of this op amp? This zero is not truly zero. This will be some small quantity, let's say alpha, okay, instead of zero. In that case, common mode rejection ratio will be equal to A by alpha and not exactly infinite. So in this question, we have been given that differential amplifier has so differential gain is 48 dB. Our common mode gain is 2 dB. Can anyone tell what will be the ratio of common differential mode to common mode gain? Okay, someone has written 25. Anyone else?
46D.
46 dB. Okay, so can anyone tell why it will be 46 dB and why not 25 dB or maybe 24 dB?
48 minus 2 dB.
Correct. So what happens is all the explanation that I have done over here is in linear scale. So this is linear gain, voltage by voltage gain. Now what happens is when you write it in decibels, we have if our gain in linear scale is linear gain is equal to A, then in decibel gain will be equal to 20 log times A. This will be our gain in decibels. So what will be our common mode gain? So a differential mode in dB will be 20 log 10 of A diff. Our A common mode gain will be 20 log 10 of A common mode. Now, what will be our common mode rejection ratio in decibels? 20 log 10 of A diff by A common mode. Now, what will happen is division inside log will be subtraction when you take the log of both of them. So it will be basically 20 log 10 a diff minus 20 log 10 a common mode. So if the gains are given in decibels and you are to find the ratio of the gains, you will subtract it. If it is given in linear scale, you will take the ratio. Is the concept of a common mode rejection ratio and the gain in decibels clear to you guys? Is there any doubt? If there is any doubt, you can stop me in between and ask. Okay, so let's move to the next question. The op amp given, so again, now here we don't have a ideal op amp. Okay, the gain of the op amp is given to be 100. In that case, output by input is required to be found out. Okay, so let's try to find out the output by input. So initially, let's have this op amp's gain as a variable A. Okay. So in that case, what will happen? Let's call this voltage as V minus. So what will be my output voltage? So in terms of V minus, what will be my output voltage, guys? Minus AV. Thank you. Minus AV minus will be my output voltage. Now, if this voltage is minus of AV minus, so now what can I write is? So can I write V minus in terms of Vs and V out? So the output impedance of this op amp, since nothing is given, so it can be assumed to be infinity. In that case, V minus can be written as R2 by R1 plus R2 times V in plus R1 by R1 plus R2 times V out. Any doubt in this? Okay, so if there is no doubt in this, let's move forward. So V minus can be substituted as, so V minus from the above equation can be written as V out by A. If we put it on over here, so we have V out by A is equal to R2 V in plus R1 V out divided by R1 plus R2. So what we have over here is all the V out terms we can take on one side. So we will have, this is minus V out by A, sorry, minus of 1 by A plus R1 upon R1 plus R2 is equal to R2 upon R1 plus R2 times Vn. Okay. So our V out by V in can be written as R minus of R2 by R1. Wait, we won't skip the steps. Minus of R2 by R1 plus R2 times 1 by A plus R1 upon R1 plus R2. Correct? So if I take R1 upon R1 plus R2 as common, so what I will have is minus R2 by R1 times 1 upon 1 by A times R1, R1 plus R2 plus 1. Now this can also be written as, if I again reciprocate it, so what I will get is minus of R2 by R1, A R1 upon R1 plus R2 divided by 1 plus A R1 upon R1 plus R2. So I'll quickly draw the circuit over here. I have R1 over here. I have A over here, R2 over here, and this is my input. So this is a standard form to write non-ideal. So this is the standard form to write the non-ideal gain of the op-amp. So are you guys familiar with a concept called loop gain? So what happens is, in case what is the loop gain? So in the negative feedback op amps, negative feedback circuit, what happens is there is some finite gain if you travel across this loop. So what do you do? So you break the circuit over here, you inject some test voltage Vt at this node, and check what is your V out over here by de-energizing this circuit, by basically making the input as 0. So what will be your gain from Vt to V out? Okay, let's call this Vt out instead of V out. So Vt out by Vt is equal to, so if this is Vt, this will be minus of A times Vt, and V out will be this voltage divided by resistor divider between R1 and R2. Since V in is 0, so that won't be considered. So we will have minus of A Vt, A times R1 upon R1 plus R2. Okay. So this is called loop gain. Okay. So if you travel across the loop of the negative feedback that is formed, whatever gain you get is called your loop gain. Now, generally, what happens is your overall gain from input to the closed loop gain, that is from input to output, when this feedback is closed, is equal to ideal gain. So gain ideal times modulus of loop gain upon 1 plus modulus of loop gain. So you will learn more about this concept in control system, but for now you can remember this result. So what is happening? So modulus of loop gain is a r1 upon 1 r1 plus r2, and your ideal gain for this. So what is this? This is a no, inverting amplifier. An inverting amplifier has a gain of minus of r2 by r1. Okay. So we have gain of ideal, that is minus R2 by R1, times loop model, the absolute value of loop gain upon 1 plus loop gain. And this is what we have over here. Is this clear to you guys? Now, what will happen if the A tends to infinity? In that case, loop gain upon 1 plus loop, so loop gain will also tend to infinity, and infinity upon 1 plus infinity will be, this term, as the A keeps on going to infinity, will be equal to 1. So in that case, you will almost approach the ideal value, that is minus R2 by R1. Is this clear? Guys, is this clear? Okay, so I hope this is clear. So in that case, we can quickly substitute the values. So our V out by Vn, or Vs in this case, will be equal to minus R2 by R1 times A R1 upon R1 plus R2 divided by 1 plus A R1 upon R1 plus R2. Okay, so substituting the values, what we have is minus 10 times 100 into 1 by 11 divided by 1 plus 100 into 100 by 11. Okay, so this is equal to minus 10 times 10 by 11. Sorry, 100 by triple one. Is this clear? Yeah. So this roughly amounts to minus some 8.9, which is roughly equal to minus 9. Is this clear, guys? Any doubt in this? Okay, so let's move forward to the next question. So in the op-amp circuit shown, Vi is equal to sine omega t plus phi. Find the maximum value of maximum and minimum values of phi in radians. Okay. So it's not the maximum value, minimum value of phi of input in radians. So what we will have is, so let's say the input is V1 times sine omega t. So our output will be some V2 times sine omega t plus phi. Now, depending on what your omega is, your output can be your phi will change, correct? So we need to find out what is the maximum and minimum value of the phase difference between the input and output. Is this clear? So you guys are familiar with reactive impedance, I suppose. So we will try to solve for the transfer function from input to output and then see what is the maximum value our phase can get. So first of all, you guys know this, right? So if let's say there is some input V in that passes through a frequency dependent uh, block. So your output will be magnitude of V in. Let's say V in is some A sine omega t. So your output will be magnitude of H times A sine omega t plus the phase response of H. Is this concept clear to everyone? I hope you guys are familiar with Fourier and Laplace transforms, right? Guys, can anyone confirm? Okay, so I hope it is clear to everyone that so this is so A sine omega t is called eigen function of the any transfer function. So if A sine omega t is given as the input, your output will be magnitude of the transfer function plus times A sine omega t plus the phase shift that this thing gives. Okay, so the same thing we will, so this transfer function we will need to find from input to output, and then we can tell what will be our maximum and minimum phases. Okay, so let's try to find out. Now, if the op amp is given ideal, our both negative and positive terminals will be virtual short. Okay, so what will be V plus? V plus can be written as the impedance divider between this resistor and this capacitor. So that will be 1 upon SC upon divided by R plus 1 upon SC times VI. Okay. So this comes out to be 1 upon 1 plus SCR. Okay. Now what will happen is so this is basically a low pass transfer function. You guys understand what is a low pass transfer function? What is a low pass transfer function, guys? Vinod, can you tell me what is a low pass transfer function?
It will pass only the low frequency signal.
Correct. Low pass transfer function is the one which passes only the low frequency signals and blocks the high frequency signals. So what happens is when so S, if you replace by j omega, so what is here that we have is 1 plus j omega RC times Vn. Okay. Now, if omega is equal to 0, that is a DC signal or a very low frequency signal, your V plus will be equal to Vn. And if your omega is very high, in that case, this will almost go to 1 upon j omega RC times Vn. Now, if omega tends to infinity, your output will be V plus will be 0. So this is a low pass transfer function. And this particular form over here is called pole of the circuit. Okay, so V plus we have found out. Now V plus will also be equal to V minus. So what we have is, so we have V minus over here. So the current that flows from input is Vi minus V minus by R1, correct? So I will be equal to V1. Wait, I will redraw the circuit over here. I have R1 over here. This is the capacitor, this is the resistor, and here is the feedback resistor RF. Okay, so the current flowing in this direction will be equal to Vin minus V minus by R1, and the output voltage will be Vin, sorry, V minus minus of Vin minus V minus by R1 times RF. Is this clear? I hope this is clear, guys. So basically what we will have is V minus times 1 plus RF by R1 plus Vn, sorry, minus Vin times RF by R1. Okay. So V minus from here we can substitute. So this is V minus. So our output voltage will be equal to Vn times 1 plus RF by R1 times 1 upon 1 plus j omega RC plus RF by R1. Okay. Now, can anyone tell me what is the maximum and minimum phase to which any signal goes? So, what will be the minimum phase difference? When will be the phase difference between the input and output be minimum? So, what is the phase, guys?
When omega tends to zero.
When omega tends to zero. When omega tends to zero, this complete gain from input to output will be a real number, right? And real number has zero phase, correct? And what will happen is, and what will happen? What will be the highest phase that this thing can go to?
Minus pi, I guess.
Minus pi. Are you sure?
90,
Sorry,
90, 90 degree.
90 degrees. And why it is so? 90 degrees or minus 90 degrees?
Phase means negative and positive both are same.
No, but so if V out by V in is equal to this, so when it will happen? When will the phase you think will go to 90 degrees?
Omega tends to infinity.
Omega tends to infinity. Are you sure it will go to 90 degrees? So what is the gain when omega tends to infinity, guys?
RF by R1.
RF by R1, right? What will happen is this complete thing will go to zero. Why? Because as the omega tends to infinity, the denominator will keep on increasing and increasing, and this complete term will go to zero. So what we will have is this will be minus, sorry, minus of RF by R1, correct? Now, what is the phase difference between input and output?
Here it's minus pi.
Minus pi or pi. Okay, minus pi and pi both have same this thing. Why? Because if you go from here, you will say it's pi. If you go anti-clockwise, you will say minus pi. But both time you reach the same this thing. Okay, so basically, what happens is, how does the phase of this complete thing looks? Or first of all, so let's try to plot the magnitude and phase response for this system. So first of all, we'll try to plot the magnitude response. So at omega equal to zero, our gain will be equal to gain will be equal to, guys,
Once.
one, correct? So it will start from some gain of one, and let's say RF is greater than R1. So at very high frequencies, what will happen? Our gain will go and settle somewhere over here, RF by R1. And how will the phase response look? So this is our magnitude response. Our phase response will look like. So at omega equal to zero, our our phase will be zero. And then as the omega starts increasing, our phase will start to drop initially, and then it will finally come at pi. Okay. So somewhere in between, it will go to somewhere in between, it will go to zero minus pi by two also, but eventually it will settle at pi, because at omega equal to infinity, our gain is or minus pi for that matter. Is this clear? So why will the phase keep on reducing all the time? Okay, so this is homework that you guys will need to understand. Redo this complete transfer function, and verify that the phase will start from zero and will eventually go to minus pi, and it will keep on falling always. Okay. So try to maybe reorganize this equation and you will get the answer for that. So you guys can try this out at your homes and we will go from here, go from there. Now, the seventh question that we have is, so what will be the output if the input to the given circuit is the sine wave? Now, let's say the op amp's gain is infinity and it has a power supply of VDD and ground. So, if the input is a sine wave, what will your output look like?
Square.
Square wave, correct? Why? Because when the input to the negative terminal is positive, the output will go and saturate to ground. It will try to go to a negative value, an infinite minus infinity value. But since the power supply is limiting it to ground, so it will settle to ground. When the output is a negative value, the power supply will go and settle to VDD, and this will keep on happening as you have this sine wave. So your output will look like a square wave. Is this clear? So op amp can only source finite voltage, output voltage, depending on the power supply. Ideally, it should have been a sine wave with infinite amplitude, but since we are limited by the power supply, so instead of minus infinity, we will have zero. Instead of plus infinity, we will have VDD. Is this clear?
Okay.
Okay. So let's move to the next question. So we have been given a circuit over here and we need to find out the current that is flowing through the load resistance RL. Okay. So can you guys tell me how about you will try to solve this question? How will you try to solve this question?
Since we have negative feedback, first we'll find the output voltage. Then from the output voltage,
Okay.
we'll
So first of all, are you sure that it is in negative feedback?
yeah, because in the negative direction it's R1 and R1. In the positive side it's R2 parallel RL and R2. So the voltage will be less. Means from negative side will dominate.
Correct. So I will just explain what Soham explained currently. So when we have, so in this case, actually we have a connection both on the negative side and on the positive side. So how will we determine whether the op amp is in negative feedback or positive feedback? What we will do is we will break both the loops. Okay, give a test voltage at the output and see what happens de-energize the input and see what happens at both positive and negative terminal. Now if some output positive output is given over here, there will be resistor divider from on the negative side, there will be resistor divider on the positive side. Now resistor divider between the on the negative side will have R1 and R1. So R1 divided by R1 plus R2 is equal to zero point 0.5. Okay. On the resistor divider on the negative positive side will have R2 parallel RL divided by R2 plus R2 parallel RL. Now R2 parallel RL will certainly be less than R2. Now, if this side resistance is less than R2, in that case, what will happen? the resistor divider between R2 and some resistance less than R2 will always give a quantity less than 0.5. Okay. So on minus side, we have zero point 0.5. On plus side, we have some quantity less than zero point 0.5. So this op amp, since the negative feedback is stronger than the positive feedback, so the op amp is overall in negative feedback configuration. Is this clear? Okay, what would have happened if instead of this RL being connected to ground, this connection was not there and we had RL like this? Will the op amp still be in negative feedback?
Yeah, still it would have been less than 0.5. No,
Now it's ulta, right?
yeah, the positive side would dominate.
The positive side will start dominating. This gain from output to the positive terminal of the op amp will become greater than zero point 0.5 because just back of the hand you can remember this. So if there is a resistive divider between two inputs, so let's say this is R1, this is R2. Now if R1 equal to R2, the V out, so V out by V in, so let's tabulate this. So if R1 equal to R2, V out by V in is equal to zero point 0.5. If R1 is greater than R2, then V out by V in is less than zero point 0.5. If R1 is less than R2, V out by V in is greater than zero point 0.5. So you can just remember this. So if the RL is connected in parallel to the feedback resistance, then this R1 will, so this resistance will become smaller than R2. In that case, your V out by V in will be greater than zero point 0.5. However, here it was zero point 0.5. So in that case, the op amp would have become a negative feedback, positive feedback. But anyways, since here the op amp is still in negative feedback, so we can try to solve this question using virtual short. We have R2 over here, some RL over here, R2, and this is connected. Okay, so if this is V out, what will be this voltage? Can anyone tell me what will be the positive terminal of the voltage? Positive terminal of the op amp, what its value will be? Okay, from this resistor divider side, we will have R2 parallel RL upon R2 plus R2 parallel RL. This is equal to V plus. What is V minus? That is equal to Vs by 2 plus V out by 2. Is this clear to all of you? And since this is a virtual short between these two, so both of them can be equated. So R2 parallel RL upon R2 plus R2 parallel RL times V out is equal to Vs plus V out by 2. So what we will have is V out times R2 parallel RL by R2 plus R2 parallel RL minus 1 by 2 is equal to Vs by 2. So we will have V out by Vs as 2 R2 parallel RL minus R2 minus R2 parallel RL divided by 2 times R2 parallel RL. Okay, so we will have over here is R2 parallel RL minus R2 divided by 2 R2 parallel RL. So this is our gain from output to Vs to V out. Now V plus we need to find out, right? So V plus will be R2 parallel RL minus R2 divided by 2 R2 parallel RL times R2 parallel RL divided by R2 parallel RL plus R2 times V in. Okay, so we will have V in by 2 times R2 parallel RL minus R2 divided by R2 parallel RL plus R2. Okay, so we can solve this further, and if we try to solve it further, what we'll get is R2 RL by R2 plus RL minus R2 divided by R2 RL by R2 plus RL plus R2 times V in by 2. This is equal to V in times R2 square divided by R2 RL plus 2 R2 RL plus R2 square. So the current that will be flowing from flowing in the load is the load current will be V plus divided by RL, right? Uh, just turn it. Here will be 1 by 2. V in by 2 RL R2 square upon Okay. Now, if RL is tending to almost zero, so RL is much smaller than R2. In that case, what will happen is we will have our load resistance as, so V roughly load current will be V in by 2 RL times R2 squared by R2 squared. This 2 will be cancelled, so we will have V in by 2 RL. If RL is much smaller than the load resistance is much smaller than the uh, R2. Okay. So you can go through the algebra by yourself and try to verify this. Is this clear? So the equation, the options didn't have this. The options were incorrect, I suppose. But yeah, is this calculation clear to everyone? Okay. So please try to do it by yourself also. Now, ninth question asks is what ninth question asks is the both the input and the both the plus and minus terminal of the op amp are connected to each other, and the gain of the op amp. So the gain of the op amp is given as 10K, and there is some there is an offset of 5 millivolt at the input of the op amp. Okay, so it's asked that what will be output voltage in this configuration. Now, when the offset is given as 5 millivolt, it can be either so it's a offset is always due to random mismatches. So it's always a statistical term. So offset given as 5 millivolt will be a sigma of the actual offset. So when you try to pick the op amps up, so some op amp can have 5 millivolt in them. Some will have let's say minus 5 millivolt. Some will have some maybe minus 3 millivolt, and there will be a complete spread. Okay, but the sigma of the sigma or the standard deviation of the offset is given as 5 millivolt. Now this can be either plus 5 millivolt or minus 5 millivolt. It cannot be determined for sure. But what will happen is, in both the cases, the gain of the op amp is so high so that the output either will saturate to plus 15 millivolt, plus 15 volts, or minus 15 volts. So your output of the op amp will be 15 volts or minus 15 volts, depending on the sign of the offset that you have. Is this clear? Okay. So let's move to the last question for the day.
So whether this you are multiplying with A, or how come you're getting plus?
Sorry,
Just it's based on VCC, supply
it's
voltage.
yeah, it's based on the supply voltage. So if 10K is multiplied by 5 millivolt, ideally output should go either to plus 50 or minus 50. Now, plus 50 and minus 50, this voltage can't go because supply voltage is limited to either plus 15 millivolt or minus 15 millivolt. So the op amp will the op amp will saturate to either plus 15 millivolt or minus 15 millivolt.
Okay.
Yeah. Now, last question of the day. Which type of amplifier has an output voltage equal to average of all input voltages? Can anyone think of circuit which will have average of all the input voltages? So it will be non-inverting average amplifier. How will it look like? So we will have non-inverting configuration, means input is given at the positive terminal, and it will look like as follows. So let's say we have n resistors and n input over here. So I will just give the answer quickly. The output will be V in by, we will have some n inputs over here. The output will be V1 plus V2 plus so on, Vn divided by n. Basically average of all the inputs. So please try to actually solve this problem and verify for yourself that the output will be the average of all the inputs. Any doubts so far?
No, sir.
Okay, so if there is no doubt, this was it from today's session. Thank you for attending.
Bye.